there are two fairly important results that we want to talk about at the end of this lesson. One is a hyperbolic result. There exists a triangle in hyperbolic geometry that cannot be circumscribed. And remember what we mean there. The perpendicular bisectors of the three sides are not concurrent. That's what we're going to prove. We're going to prove that there exists a triangle for which the perpendicular bisectors of the three sides are not concurrent. So let's build it. We're going to start with a secary quad. We're going to let ABCD be a secary quad. Suppose we are given secary quad or chiom quad. ABCD with AD congruent to BC. Let the midpoints of AB and CD be E and F respectively. Choose G on EF, ray EF, right? There's EF, such that EG is congruent to AD. So what do we know? We know that when we connect the midpoint of the summit to the midpoint of the base in a secary quad, we get a line that is perpendicular to both the summit and the base. But when we choose point G such that EG is congruent to AD, well, that does something. That means that AEGD and EBCG are chiom quads. Thus, AEGD and EBCG are chiom quads. Well, why does that matter? I won't finish writing the proof, but we should consider triangle CDG. Because the perpendicular bisector of side DG is the segment you get by connecting the midpoint of AE to the midpoint of DG. That's this line. And the perpendicular bisector of side CG is the line that you get by connecting the midpoint of the summit to the midpoint of the base. That's this line. And the perpendicular bisector of side CD is FG. Those three perpendicular bisectors are not concurrent. They are all perpendicular to the same line. And two lines that are perpendicular to the same line must be parallel. And so in hyperbolic geometry, there exists a triangle that cannot be circumscribed. That's a key result.